The journey of a tire begins with foundational raw materials, including natural and synthetic rubbers. These raw rubber compounds are meticulously prepared for the intensive blending process. Carbon black, a critical reinforcing agent, is precisely measured and added to the mixture. Alongside carbon black, various essential chemicals and additives are carefully introduced. High-tensile steel wire, a vital component for structural integrity, is drawn and prepared. Inside the colossal Banbury mixer, rubber compounds are blended at high temperatures and pressures. The freshly mixed hot rubber compound emerges, dark and pliable, ready for the next stage. Large open mills further refine and homogenize the rubber into continuous sheets. Rubber strips are then cooled in a water bath, preparing them for precise shaping. Automated machines cut the cooled rubber into exact dimensions required for various tire components. The tread compound is extruded, forming the distinctive pattern that will grip the road. Sidewall rubber is also extruded, creating the protective and flexible outer layers of the tire. Spools of durable textile cords, like nylon and polyester, await integration into the tire's structure. In the calendering process, these textile cords are embedded within thin sheets of rubber. The resulting rubberized fabric provides critical strength and stability to the tire's body. These large rolls of rubber-coated fabric are then precisely cut into strips for the plies. Steel wires are coated with rubber, forming the robust bead that anchors the tire to the wheel rim. These coated wires are then expertly wound into strong circular bead bundles. On a tire building machine, the inner liner, a critical airtight layer, is carefully applied. The first ply of rubberized fabric is then meticulously wrapped around the building drum. Subsequent layers of plies are added, gradually building the tire's internal framework. The preformed rubber sidewalls are positioned and affixed to the tire's growing structure. The sturdy bead rings are then precisely seated, forming the critical edge of the tire. Finally, the tread strip, with its nascent pattern, is applied to the tire's exterior. The resulting green tire is a flexible, unvulcanized form, lacking its final rigidity. These green tires are conveyed to powerful presses, awaiting the transformative curing process. Each green tire is placed into a heated, intricate mold, designed to impart the final shape and tread. The immense curing press closes, applying heat and pressure to bond and solidify the rubber. Within these presses, the chemical process of vulcanization permanently strengthens the rubber. After a precise curing cycle, the hot, fully formed tire emerges, hardened and with its distinct tread. Excess rubber flash is meticulously trimmed from the cured tire's edges. Each finished tire undergoes a thorough visual inspection for any surface imperfections. Cooling racks allow the newly vulcanized tires to gradually reach ambient temperature. An advanced X-ray inspection machine scans the tire's internal structure for hidden flaws. Digital displays provide detailed internal images, ensuring structural integrity at every layer. Tires are spun on balancing machines to detect and correct any uneven weight distribution. Uniformity testing rollers precisely measure radial and lateral force variations, ensuring smooth operation. Automated systems sort and stack the approved tires, ready for storage and dispatch. Vast warehouses hold towering inventories of finished tires, awaiting their journey to market. Finally, completed tires are loaded onto trucks, prepared for distribution to destinations worldwide.